Relative atomic masses are used to compare the masses of different atoms. Relative atomic masses can also be used to compare the masses of molecules in different compounds. The relative masses of compounds are called relative formula masses, with the symbol Mr as opposed to Ar as seen with relative atomic masses. Now, the relative formula mass of a compound is the sum of the relative atomic masses of all the atoms in its formula. Let's start off with an easy one. The formula for a molecule of water is H2O, so the relative formula mass of water is. Here we have 2 hydrogen atoms and 1 oxygen atom. So in this case, we're going to multiply the mass of hydrogen by 2, which is 2, plus the mass of oxygen, and by referring to the periodic table, we can tell it's 16. So 2 plus 16 is 18, and this is the formula mass of water. Let's have a look at the relative formula mass of calcium carbonate. Its formula contains 1 calcium atom, 1 carbon atom, and 3 oxygen atoms. We can first start the calculation by determining the relative atomic masses of each of the different types of atom. So calcium, with reference to the periodic table, has a mass of 40. Carbon has a mass of 12, and oxygen has a mass of 16. If we put those masses into the formula, we'll get 40 plus 12. We'll have to multiply 16 by 3 because we have 3 oxygen atoms in this case. This will give us a relative formula mass of 100. So now it's your turn. Try and work out the relative formula mass of sulfuric acid. How did you do? Let's go through the calculations. So step 1, we need to identify the different atoms present in the formula. So in this case, we have hydrogen, sulfur, and oxygen. Step 2, identify the number of different atoms present. So in this case, we have 2 hydrogen atoms to 1 sulfur atom to 4 oxygen atoms. Step 3, look up the relative atomic masses, RAM or AR, of the atoms by referring to the periodic table. So the RAM, or relative atomic mass of hydrogen, is 1. The RAM of sulfur is 32, and the RAM of oxygen is 16. Step 4. Calculate the relative formula mass, RFM or MR, by using all the information in step 1, 2 and 3. So the calculation would be the mass of hydrogen multiplied by 2 plus the relative mass of sulfur plus the relative mass of oxygen multiplied by 4. And this will give us a relative formula mass of 98.